This is an AIPMT question in gravitation. Question says that Kepler third law says T square is directly proportional to kr cube, where k is constant. Masses of the sun, planets are normal general terms. Newton law of gravitation is a known value. G is a gravitational constant. Relation between G and K is how much, right? So we will go to the core of the scenario and see what is happening, right? Let us consider sun and let us consider a planet. Assume that this planet is revolving around the sun with a radius r. Then the sun is definitely having some mass. This planet is also having some mass. Planet is revolving around the sun because sun is applying a gravitational force on that. How much is that gravitational force is as per the Newton law of gravitation? G m1 m2 by r square. But as the planet is moving in a circular orbit, there must be always a centripetal force, and centripetal force is never an outside force. The force acting towards the center itself is a centripetal force. Thus here the gravitational force between the bodies is behaving like a centripetal force. One r can be cancelled, one mass of the planet can be cancelled. That implies the square of the velocity equal to g capital M by r, or velocity with which that planet is revolving at the given point is root of gm by r, where r is the distance between the sun and the planet. But because it is in a rotatory motion, we can also get into the other relation like v equal to r omega. R omega after one revolution could be written like omega is actually d theta by dt. After one revolution, angle covered is 2 pi. Time period for the time taken for covering that revolution is called time period t. So from this I can write time period equal to 2 pi r by v. Once after knowing this time period, we can go to the core rule that was being said here, that according to Kepler's second law, t square is directly proportional to r cube, right? See, how do we get the t square equal to r cube? From here, I got t now, let's find out t square. It becomes 4 pi square r square by v square, where v is the velocity of the planet with which it is revolving in the orbit. But we have already derived an equation for that. Let us substitute this value v square in this equation. Implies t square is 4 pi square r square by, in the place of v square, I can write gm by r. It implies t square equal to 4 pi square. This r goes to the numerator and it becomes r cube by gm, right? Now, as 4 pi square by gm is a constant, we can say t square is directly proportional to r cube. Comparing this with the standard equation that was given in the problem, t square equal to kr cube here in the problem, we can say constant k here is equal to 4 pi square by gm. You want the value of, and look at the options, you want something like gk or gm into k. Let is gm to this side, it becomes gm into k equal to 4 pi square. That option is available. Who is a obviously a right answer, right? So in solving this problem, we have used some basics. First, let us try to get what we have used, right? As the planet is revolving in a circular orbit around the sun, centripetal force is provided by gravitational force. Basing on that, I have calculated velocity. Linear velocity and angular velocity relation is v equal to r omega. From that, I got time period value. From there, I have calculated t square, which I found that some constant into r cube. So that constant is called as k in the problem. I can equate this 4 pi square by gm to that k. I have done that and got an answer, right? So go through the problem once again, and if you have any concern, please make a comment so that I'll have a look into that. Thank you for watching.